24th of April, further maths 5 a day, and let's just go straight with the first question. Right, looks like an index rule question. Again, I'm thinking powers of 2. I mean, I could do powers of 16 or 32 or something silly, but powers of 2 seems to make it easier. 4 is the same as 2 squared, so I'm going to write this as 2 squared to the power of 5 minus 6x. Now I'm going to do this in one go. So 32 is 2 to the power of 5, but it's upside down, so 2 to the power of minus 5 to the power of x minus 3. Let's be really careful with those brackets. Okay, let's do the step in between. So the left-hand side is 2 to the power of 10 minus 12x, and the right-hand side is 2 to the minus 5x plus 15. Now, because the base values are equal, it means the powers must be equal. So 10 minus 12x is equal to minus 5x plus 15. Add 12x to both sides, I get 7x. Take away 15 from both sides, I get minus 5. And so that means that x is equal to minus 5 over 7. And that is question done. Not too bad. And it looks worse than it is, but not too bad. Next question. Okay, we have simultaneous equations. They've made it quite easy for us because they've got y equals and y equals. So in other words, I'm just going to say that x is equal to x squared minus 9x minus 3 because y equals y. Move the x to the other side, so 0 equals x squared minus 10x minus 3. Now, can I factorise? No, I can't, because two numbers that multiply to make 3 are not going to add to make 10. So that's definitely not going to work. So it's going to have to be a quadratic function or completing the square. Just to be different, let's do completing the square. So that's going to give me x minus 5 squared minus 25 minus 3 is equal to 0, which is the same as x minus 5 squared equals, or 25 plus 3, both negative, is 28. And so that's going to be, well, let's bring it up here. X minus 5 is equal to plus minus root 28, which means that x equals 5 plus minus. Now, just to be neater about it, 28 is the same as root 4 times root 7, which is the same as 2 root 7. So I'm actually going to write this as 2 root 7. Now, let's not lose track of what we're trying to do. So we're trying to solve the simultaneous equations. So whatever y is, x is equal to the same thing because of this here. So therefore, the coordinates that solve my function are going to be 5 minus 2 root 7, and the y value is the same, 5 minus 2 root 7, or 5 plus 2 root 7, and 5 plus 2 root 7. And of course that makes sense, doesn't it? Because if I draw a circle, and then I draw a straight line with the equation y equals x, they are going to be opposite symmetrical, if you see what I mean by that. Good question. Next one, use Pascal's triangle to expand. Now, because it's to the power of 3, I know my coefficients are going to be 1, 3, 3, 1. And actually, let's just write it underneath here. So it's going to be 5x cubed, it's going to be 5x squared, and it's going to be 5x, and then 5x to the 0, but I won't write that. And this will be 9 to the 0, 9, 9 squared, and 9 cubed. Now, if this is a non-calculator question, that's not very nice, but I suspect you might be able to use a calculator here. Either way, I'm going to do it just to make sure I get the right answer. So the first one is, I'm looking at this here, is going to be 1 times 5x cubed. Well, 5 cubed is 125, times 1 is just going to give me 125x cubed. The second one, this one here, is going to be 3 times 25 times 9, which is 675 x squared. Okay. The third one, so I'm now looking at this one here, is going to be 3 times 5, well that I can do, times 81, okay, back to calculator, which is going to give me 1215x. And the final one is going to be 9 cubed, and actually I do know what that is, which is going to be plus 729. And that is it, question done. Not too bad, that one, but the numbers make it look worse than it is. Next and final question today. Solve. Now, anyone that's seen my videos knows what's the next sentence is going to be. Let's try and factorise. I will say, not all of these, I have seen questions where these don't factorise. And where they don't factorise, I mean, they will on a non-calculator, probably. But where they don't factorise, you then have to just use some surds in your answers. But typically you get some nice numbers here. Either way, let's give it a go. So 5x and x, because the factors of 5 are 5 and 1. This is a minus and this is a minus, which means one of these is going to be a minus and one of these is going to be a plus. Bit annoying. And then this one here, it's slightly bad thing to factorise this. I've got 1 and 24, 2 and 12, 3 and 8, 4 and 6. So the problem is I've got quite a lot of choices here. So I need to get two choices that multiply by 5 and add to make minus 7. I have to say, I kind of wish I'd gone the other route now, because this could be a bit of a guess. Let's just try some numbers. Let's start with in the middle, right? 8 and 3. Actually, that has worked, hasn't it? Because if I put my 8 here and my 3, well, that was lucky. Sometimes luck does work out. 5 times minus 3 is minus 15, and 8 times plus 1 is plus 8, and minus 15 plus 8 is minus 7. Okay, that was a bit of luck. I have to say, I was very close to just calling it then and just doing either a quadratic function or doing the algorithm method. The algorithm method would also be annoying because 5 times 24 is 120. Lots of factors there as well. So I have to say, if I was in an exam, I probably would have just done the quadratic formula and just got the answers. So let's pull the whole question together. This is a quadratic inequality, so my critical values are going to be minus 8 over 5 and 3. Always sketch, so a quick sketch here tells me that this is minus 8 over 5 and this is 3. And I want all values that are greater than, in other words, all values that are above the x-axis. So therefore I want the values that are greater than 3, and I want the values that are less than minus 8 over 5. Then I'm going to go back and check the question quickly. So the question is 8 greater than or equal to, so I must also have less than or equal to or greater than or equal to in my answer as well. And that is my final answer. And that is indeed today done. Again, as ever, good mix of questions today. By no means, we haven't seen one of those in a while. Question 2, really sort of clever, symmetrical question, a nice indices question to start. Let me know how it went for you. Do like, subscribe, and I'll see you tomorrow.